Find the linear approximation of f of x equals natural log of x at x equals 1 and use it to estimate natural log of 1.25. Okay, so what are we talking about? Well, we have this function, natural log of x, and we want to approximate it. Now you can see the answers already here, but let me show you what we just did. And I'll show you how we get there, but let me show you what the result means. Here's a graph. So the red is natural log of x. That's that curve right there. That's natural log of x. And then the blue is x minus 1. And so that blue line is x minus 1. Notice they meet right here at 1. That's the tangent line at 1. And notice right around this area, the blue and the red are basically right on top of each other. They're basically the same. So that's the idea that a curved graph is the same as a straight line right around where they intersect. That's the tangent line. Right around there, they're very, now if you get way over here, the blue line, the red line are really different. You get way over here, they're very different. But right around where they intersect, they're pretty darn close. So in upper math and science, we use straight lines to estimate curved graphs because straight lines are easier to work with. So how do we do it? Well, basically, what we do is we find, whenever they say find the linear approximation, what that really means is find the tangent line. And we've done that before. I mean, the tangent line y equals mx plus b. That straight line, again, that blue straight line that barely nicks the curve right at that one point. So find the tangent line at x equals wherever they tell us. In this case, x is 1. Well, how do we find the tangent line? Well, we got to find the slope, right? The mx plus b, the m's the slope. So how do we find the slope? The slope is the derivative, isn't it? It's going to be f prime of x. So here's the function. Let me write that up above here. So the function f of x is natural log of x. So what's the derivative of that? Well, I don't know if you remember, but it's 1 over x. The derivative of natural log is 1 over x. So now, and we're supposed to find it at x equals 1. So let's find f prime of 1. That's 1 over 1. That's 1. That's easy. Okay, so we've got the slope. So we come up here and we say, okay, so our slope is 1. And so put that in right here into the equation. So we have y equals 1x plus b. Now we need to find b. How do we find b? Well, we know we're at x equals 1. Okay, but so we're going to plug in x equals 1 in a minute, but what's the y value of the function? Well, the original function is f of x is natural log of x right here. And if we plug in 1, we get natural log of 1, and do you know what that is? It's 0. You can check it on Desmos if you want. Here, I'll go back to Desmos real quick and put in, here, let me clear what I've got, natural log of 1. So if I go to functions, go natural log of 1, see there it is, it's 0. Natural log of 1 is 0. So I go, okay, so what does that mean? Well, that's the x, that's the y. Remember, whenever we plug into a function as x, whatever it equals is y. So that means that's x is 1, y is 0. They're going to meet at the same point because right at that point, that's the intersection point between the curved graph, this is the natural log x graph, and the straight line, which is the tangent line. They both meet right there at over 1. See, you can tell what that point is. That's the point over 1 up 0 right here, isn't it? So they meet there. That's the x. Whoops, I made it move now. That's the x, that's the y, 1, 0. Okay, so back to it then. So now I can plug into this. I get 0 equals 1 times 1 plus b. 0 equals 1 plus b. Jump this to the other side. B is negative 1. So now I've got the equation. It is y equals mx plus b. It's y equals m is 1. B is negative 1. So there is the equation of the tangent line. So that's how they got that first answer. That's the equation of the tangent line, that blue line. That's the equation of this blue line. You can tell it intersects the y-axis at negative 1. Its slope is 1. It goes up 1 over 1, up 1 over 1. So that's the equation of that line. So again, how do we do that? We took the original function, natural log of x, and we took the derivative of it, got 1 over x, then plugged in x is 1 because they told us x was 1, got 1, that's the slope, that's the m is 1. Then we wrote y equals mx plus b, put in the 1 for the slope, and then how do we find b? Well, we had to plug in an x and a y. We had an x is 1. We had to get the y by plugging into the original function because they're going to have the same y. They're going to intersect at the same point. So I plugged in 1 to the original function, and right there, natural log of 1 is 0. So when x is 1, y is 0. X is 1, y is 0. Solved for b. B is -1. And there it goes. Okay, so now we have the equation. Now it says then the natural log of 1.25 approximates, see that shaky equal sign there? That means not exactly equal, but approximately equals what? Approximate to at least 7 decimal places. So how am I going to do that? Well, we're saying that this equation right here, this tangent line, is what? Approximately the same as y equals natural log of x, our original function. Right? They're approximately the same. You can see they are, at least right around x is 1. The blue line, the red curve, they're about the same around x is 1. So they're really close to the same, approximately the same around x equals 1. So if you want to know 1.25, natural log 1.25, that means you can just plug in 1.25 right there to this because it'll be close, right? You plug in 1.25 to the natural log function, you plug in 1.2 to this function, 1.25 to that function, they're going to be very close to the same. What do we get? 1 times 1.25 minus 1. Well, that's easy. That's just 0.25. There we go. And that is indeed our answer. By the way, what's the real? Right, we're saying that's approximately equal to the natural log of 1.25. Right there, you can see they're very, very close. What is it really? I don't know. Let's go back and find out. What is the real natural log of 1.25? Let's find out. I'll go back. Make that 1.25. See how it's what? 0.2231, blah, blah, blah. So it's pretty close to 0.25. It's not exactly the same, but it's pretty close. So there we go. There's the approximation, and that's how we do that.